Welcome to the world of airless shredding. The equipment you see before you operates as a self-sufficient single-stage reduction and baling system, capable of processing up to 25 tons per hour of printing waste without the use of pneumatics for material transfer. Over the years, printing equipment's size and speed has grown considerably. As a result, the amount of waste generated has grown as well. These changes, along with increased hauling and disposal handling costs, have led to a new trend in processing all grades in-house. You are about to see 4 different grades of printing waste processed into saleable form by this airless system. But first, let's run through the basic components and take a closer look at some of the available features. The Airless Shred system is comprised of 5 main components and 2 ancillary components. The first main component is the in-feed conveyor, which is a combination belt design incorporating the strength of a chain with a lower cost and lower maintenance of a belt. All wear points are lined with replaceable UHMW, and the inclined section acts as a self-leveling regulator to help maintain a uniform feed rate to the shredder. Second, and the heart of the system, is the rugged XL Series shredder by Williams, which uses no sizing grates to obtain material reduction. Rotor design and overrunning rotation creates a through flow pattern that gives the XL its unique and patented self-discharging capability. Horsepower varies with tonnage rate desired and ranges between 100 and 400, which is comparable to fan horsepower alone on a similar tonnage pneumatic system. The key to the airless system not only lies in the shredder design, but also in the special hopper fitted to the shredder discharge that recirculates a portion of the output. This results in the dissipation of the discharge velocity and allows the material to quickly settle on the takeaway belt. The third component is the takeaway or transfer conveyor. This combination belt is totally enclosed and carries the material to the baling press in place of the fan and piping arrangement found in a typical pneumatic system. It is this component that realizes the greatest power savings. For example, a 15-ton per hour system requires a 200 to 300 horsepower fan to carry material. Compare that to the 10 to 15 horsepower required on this conveyor. That's quite a difference, and the savings it generates is year after year after year. The fourth component is the mag conveyor. This sidewall slider bed incorporates a magnetic head pulley to extract ferrous tramp metal prior to baling. Not shown but provided as a standard feature is a tramp chute for collection of the extracted metals. The last main component is the Autotide Baylor. This particular system utilizes a high-tonnage 8000 series wide-mouth horizontal press by American. This model is capable of handling all grades generated by this plant and features a keypad access to the PC for adjusting the baler operation to each grade. Dual 20-horsepower fluffing units are fitted into the extended hopper section, providing a low-horsepower, high-tonnage alternative to shredding sections, signatures, or other bulk wastes not requiring size or security reduction. Material is fed to the fluffers via a separate loading section located at the tail end of the transfer conveyor at rates up to 25 tons per hour. The remaining components constitute a subsystem for dust control, which is highly recommended if you plan on running cores or white waste. The natural airflow generated by the shredder rotor is relieved through pickups located along the top cover of the transfer conveyor. Fine particulate is conveyed to the filter for removal from the airstream, which continues free of dust through the 15 to 20 horsepower balance fan and then re-enters the plant air through a diffuser. Fines are collected at the bottom of the filter and can be disposed of by a number of available options. During the upcoming operational sequences, notice the negative pull under the mag conveyor and the lack of dust in the surrounding environment at any given time. A quick look at some of the other features inherent to the system reveal pit-style in-feed sections for quick loading and easy cleanup, full rotor access cover and direct drive motor, overload control with variable set point for processing different grades, simple control and starter panels, pre-wired programmable baler panel, expanded cleanout panels that double as chain guards, automatic swing-away hydraulic fluffer doors, 1,000-pound coil stands for less handling and setup time. Spark detection and extinguishment system with self-monitoring controller. And fully covered drives on all components. Now that we've covered the basics, let's run some product. Here we see a skid of roll-form white waste being loaded onto the infeed conveyor. And self-leveling at the curve to the inclined section. Notice the orientation of the rolls to the conveyor. The shredded rolls are carried up the transfer conveyor, over the mag conveyor, and down into the baling chamber. Notice the density at this point. And at this point. The next grade we'll process is a mixture of corrugated in-container and roll cover forms. Although this material is being processed through the XL, it can be fed directly into the baler without shredding or fluffing by loading it onto the extended tail section of the transfer conveyor, seen just beyond the material being loaded. Again, notice the size and density of the material from here to here to the final product here. These are dense, well-formed, shippable bales. Cores. These pesky logs have been a problem for years, but process easily in the airless system. This is not only due to the heft and design of the shredder, but also to the transfer conveyor that readily accepts and absorbs any surges the shredder may dish out. When a surge does occur, the system sees only a slight increase in the bed depth transported to the baler. In addition, all primary shredders pass slugs from time to time, which can damage a fan blade or housing. Slugs in the airless system, however, simply discharge with the rest of the material and are carried away. No damage, no problem. Even metal end caps pose no threat to this system as they pass through the shredder and are recovered by the mag conveyor. Although somewhat altered in shape, these caps are virtually intact and ready for recycling. Try that with a pneumatic system. Seen here in the baling chamber, the shredded cores don't look much different than the corrugated we ran before, and the bales, well, we'll let you be the judge. As we watch some bulk waste and signatures make their way to the shredder, let's recap some of the airless advantages. Higher tonnage is processed with lower horsepower. Surges and slugs are easily handled with no equipment damage. Metal-capped cores are processed with no equipment damage. Ferrous metals are recovered for resale. All equipment is located indoors. No roof mounting or through holes are required. No downtime due to plugging from surges, moisture, or static. Shorter run time due to higher process rates. And finally, one system does it all. We hope you found these few minutes taken to be insightful. Thank you for your interest in the Airless Shred system from MPI.